higher ed education space. In my previous life, I spent the majority of my career in academia, in healthcare, and I spent a little bit of time in the defense industrial base working for one of our prime defense contractors here in Connecticut. So it's great to be here, and welcome to the talk. So this conversation is about the 20-watt architect. So this is a 60-watt bulb, give and take, and it has about it requires 3 times the power that our mind requires to work. So if you look around, everything that was created in this room, this entire amazing event space was created by the human mind, which works on 1/3 of the power that it takes to light up this light bulb. So as we talk about generative AI and Claude code on using Claude code and other ID agentic-based coding assistants, I'd like you to keep in mind that whatever you use, your brain is the most important tool that you have in your tool set. And welcome, go on in. And it's important that keep that in mind. If you think of how much your brain worked to get you here, did a lot of work. You had to get up, you had to interact, socialize, you had to drive, you had to jump on a car, at least a 2,000-pound automobile, put on a podcast, listen to the podcast while not getting into any accidents, and drove all the way to this amazing place. And you didn't think twice about it. And if you commute, you do that all the time. And a lot of us don't even have a recollection of what exactly happened during that commute because our brain abstracts all that heavy work and we don't really see it. So similarly, we'll come back to this in a second. I don't want to drop. If you look at what it takes to really run, for us to operate, the human brain takes about 20 watts of power. Numbers differ between 12 and 20 watts. And we design spacecraft, we write poetry, create art, drive tens of miles a day without getting into accidents, without bumping into other humans who also use their brain to avoid us. And contrast that to AI training, where it takes approximately 60 gigawatts of power to train a model like GPT-4 over 90 days. The training for that model required about 25,000 NVIDIA A100 GPUs and used enough power to power 5,000 American homes for a year. Think of the energy that it takes to train a model and then not only train it, but also use it. So we have two sides of the equation when we talk about AI training. We have AI inference, which is what happens when you ask an AI model, an LLM, questions. And it takes about 1/3 of watt-hour per query in GPT-4o. And that is 10 times more than the power that it takes to return you the answers of a Google search. Once you use coding agents, that power utilization jumps to about 40 watts an hour. And when you multiply that across 700 million queries a day globally, approximately, you see that we're using at least about 210 megawatts hours per day. And that takes a lot of power. This is just using the model. Never mind training the model, which, as I mentioned before, uses a lot of power. This is for one model, in this case GPT-4. But as you know, we have the multiple providers that train multiple models, such as we have OpenAI, we have Amazon, we train our models, and we also provide inference services to our customers as well. So it takes a lot of power to interact with generative AI, with AI models, and especially using coding agents to talk to them. So every AI interaction that you have has a cost, whether it's a cost to you, whether it's a cost to the provider, whether it's a cost to the electrical grid and your colleagues. So it's important that as you look at utilizing these models, utilizing Claude Code and other generative AI tools, that you keep in mind the energy penalty that these tools are using. So you're the human architect. You're the architect that structures your work around using generative AI. And your 20-watt brain decides what to ask and how to structure your queries and when to use generative AI and how to guide it in building the solutions that you're trying to build. So your 20-watt brain decides what to ask, which makes the system economically viable. Presumably, you're going to use generative AI, you're going to use Claude Code, you're going to build new features, you're going to ship faster, and by doing that, you're going to make this energy usage worthwhile. Let's talk a little bit about intelligence, and human intelligence specifically, which is built on layers of abstraction. Looking at bottom up, we start with physics and atoms, right? And then you move up to biochemistry, which controls how your electrical signals and your brain signals control your everything that you do, frankly. Using 100 trillion synaptic connections, and then you have thoughts and memory stitching patterns into meaning and finding language and concepts at the very top. You don't think about ion channels where you speak. You don't think of your neutrons firing when you drive a car, when you listen to podcasts or take an action. It just happens. Everything else is abstracted down from your thoughts and memory down. It's abstracted by your mind. And the same thing happens when we program. When you use coding agents to do your work and to accelerate your work. AI hides the frameworks, and each layer lets more people accomplish more without understanding what's underneath. The human brain figured this out through evolution, and now human engineers are replicating the same pattern in silicon. So what is the typical development process? You decide I'm going to write a prompt and I'm going to greet the user by their name, and then I code that in Python, and eventually it's going to make it into machine code. It's going to be interpreted and compiled into machine code, and you're good to go. Well, those of us who are developers know that that's not the case. What really happens is you think, I want to implement this function, but then you do your research. You read books, you talk to your colleagues, you reference expertise, you maybe read Stack Overflow, check out Reddit. And then, when you decide what pieces of code make sense, what architecture patterns suit you, then you write your code, which gets interpreted, compiled into machine code. But is that really the case? Well, not really, because you write your Python code, and then it gets interpreted into bytecode, and then it gets processed through a VM machine, written in C, by the way, into assembly and eventually into machine language. And then the machine does what you want it to do. So at every level, both human intelligence level and writing code, there are multiple layers of abstraction that most of the time they're invisible to you, or you may be aware of them, but you don't necessarily know the details behind them. How many of you have read assembly code lately? Nice, okay. For the majority of us, we probably haven't looked at it in a while. So this is really the key contrast between the old world and the new world. We have an execution pipeline and we inject Claude Code or other agentic programming assistants into the workflow. And before you wrote the code yourself, you manually compiled it, maybe you did some validation checking, you reference some programming docs or Reddit, ideally not that much, and then you compiled it, you figure out what the issue was, interpret it, compiled it, and it ran. Great. Now you express your intent. Claude Code looks what your intent is. It uses Anthropic's models to generate the code, the code snippets that are needed to run your program, and then the entire development pipeline just runs as usual. Same number of layers. You just replicate. You just shift Claude code, insert Claude code instead of your searching and using documents and using programming references. It's not quite as simple as that, but for illustration purposes, we'll go with this. So here's what happened when you use the coding agents. You tell Claude Code to build a feature with authentication tests, and at the top you have your human intent expressed in natural language. Claude Code interprets the intent and generates a Python source code. And that source code is compiled by Python, compiled into bytecode and stored in .pyc files. And then the CPython virtual machine executes that bytecode, and by the way, that virtual machine is written in C. Again, you don't see that. And then the ultimate code gets compiled into assembly. So a single English sentence, and it doesn't have to be English. By the way, LLMs are multilingual. You can speak to it in Romanian, you can speak to it in Spanish. A single sentence triggers a cascade through the 5 layers of abstraction, each one invented by humans over the last 70 years. So natural language all the way to Python to bytecode to C and eventually compiled to machine code. And that is the power of abstraction. Generative AI is simply the newest layer in this progression. You focus on the intent and the stack takes care of the execution. Just like your mind decides to drive to work and everything else just gets taken care of. Now, coding engines are relatively new. The evolution of AI tooling has been rapid. We had autocomplete in 2020. You hit tab and it's just the next few words, the next few coding bytes. By 2022, we had chat-based assistants for questions and code snippets. We transitioned into line editing in 2023 with tools like Cursor, which brought inline editing directly into the IDE. And lastly, in 2025, we crossed the threshold. We got coding agents. As we talk about Claude Code, I'd like to point out that Claude Code doesn't just interpret code, doesn't just suggest code, but it plans an approach, it writes your implementation, run tests, identifies failures, reruns those unit tests if you need to, it fixes them, and then it iterates through the task until the code runs according to your design after it passes the unit tests and make sure that it complies with what your desired outcome. Claude Code has a 1 million token context window, which means that it can hold the entire code base in the context in its memory at once. In a developer survey from early 2026, Claude Code had 40% was tagged by 46% of respondents as most loved dev tool in 2026, which is fantastic. We're just halfway through. And this is all to say that as you use Claude Code, you are the architect. Use your 20-watt brain to decide how you're going to use this tool to your end. It's not going to, if you use it as naively, and you give it a command, you give it a prompt, and let it do it for you without truly understanding what it does, you're going to create something, but it's definitely not going to be a ship-ready, it's not going to be a production-ready application. You still have to architect, you still have to provide your software development and engineering expertise in telling the tool how to architect that particular product that you're trying to build. What unit tests to run, what code bases to reference, what organizational data to look at and take in consideration as you build that application, and then iterate that approach. So you're the architect, you design a system, you define the constraints, you evaluate the output. You make the decisions that require judgment, context, and creativity. Claude Code is not going to replace that for you. And fortunately, those are the things that the 20-watt brain excels at. So, what is Claude Code? It's an agentic coding assistant from Anthropic. It lives in your terminal. It also has plugins for VS Code, for those of us who use VS Code. And unlike the other complete tools of the past, that just kind of suggested the next few tokens, the next few commands in a command line, Claude Code operates at a project level. You use external tools, and you interact with it through natural language. It reads your files, edits your code, runs shell commands, can access your GitHub repos, and you can do all that through natural language. the three key attributes make it different. First, it's terminal native. That means it runs where you developers already work. There's no separate IDE required. You can also plug it into VS Code if you need to. And when you give it a task, it plans a multi-step approach, executes each steps, checks the results, self-corrects when something goes wrong, and iterates until the task is complete to your specifications. It also has autonomy within the bounds that you set. So as you ask Claude Code to implement something, run a command, it's going to ask you, hey, do you want it? Are you sure? Do I have permission to do this once? Do I have permission to do this always? Do I have permission to do this for the current session? And then that's it. Once you exit, we'll start over again. I'll ask you for permissions again. So it has the guardrails that allow you to use it in a security-minded fashion, unless you give it access always to access your other systems, and that works fine. You just got to make sure that you trust the action that it takes, and you really want to point at dev environment first. Make sure that dev environment software works while you implement dev, then test, then prod. Follow the same SDLC practices that you currently follow before you would implement the software in production. As you work with Claude Code, the interaction follows typically a 6-step agentic. In the first step, you describe the task in natural language, something like add OpenAuth to Google SSO. Right? There's no syntax required. You don't have to look up how to implement that command. You just tell Claude to do it. Claude looks at its underlying models and generates that command. So it plans, it reads your code base, it maps the dependencies you may have. Maybe you already have an existing authentication SSO set up in your environment. It looks at those specs. It understands what it needs to do. And once it maps those dependencies, identifies the files, it needs to change its structures and approach. And then that moves into step 3, where it starts writing the code, it edits the files that it needs to edit, it runs whatever shell commands it may need to, installs dependencies, and then in step 4, it starts validation. It runs its tests, checks output, runs other unit tests if it needs to, verifies behavior, looks at any corner case scenarios if you have any corner cases that you want to define for it, or unique rough spots in your code that you want it to be mindful of. It looks at that, and then if everything looks good, it shifts to step 5, which frankly is an iterative steps, where adjusts any failures, fixes any failures, adjusts the approach, and then retries the previous loops, the previous steps, until it has a successful approach. And lastly, if you let it to, it delivers. It ships your code, it moves it to your Git repository, moves it to your dev environment, and submits a PR on your behalf. So the entire loop happens autonomously. You can also interject in this loop at any point. But for the most part, the intent is for this to happen autonomously. You tell Claude Code what you want to do, and then it executes against it. Again, you as an architect have to plan for it, have to define unit tests. You can define unit tests yourself. You can use existing unit tests that you have in your environment, or you can have Claude Code work with you to define those unit tests yourself. You can point Claude Code to your known good code base. If you have known good software practices and standards that are within your organization, you can point Claude Code to those data repositories, and it references that code, and it tries its best to mirror the approach to the new code that it creates based on what you already have. And the multiple levels of working with Claude Code. Most users start at the very top, where they select a model. They switch into plan mode, and they interact with the coding assistant, and they tell it what they're trying to do. They edit the Claude.md file, where they give it specific instructions on what to do and what not to do. And lastly, They give you some context. That context is very important because your organizational data has gravity, and it's really a key IP of where you work, where you will be working. So pointing this coding assistant to your organizational data is very important to keep the context, to understand what your code base looks like, to make sure that it writes in a way and it documents that the code that it writes in a way that fits your standards. Next step would be once you install Claude Code and you write a couple of sample programs with it, you really want to give it additional functionality. And that additional functionality comes from implementing and pointing it at multi-context protocol servers or MCP servers. And that's where you integrate it with other systems. That's where you can integrate it with your Jira, your Slack, your file systems, whether it's Amazon S3 or whether it's Microsoft O365. You point it to the MCP servers that in turn interact with those systems, and therefore allow your coding assistant to become smarter and get better context. Look at your chats, look at your development practices. Maybe you have a Slack channel that talks about this is how we as a team of developers will build a particular piece of software. You can read that information from your team and help it in making the decisions. As you work in the intermediate mode, you'll eventually graduate to using an advanced mode, and that's where you have Claude spin up multiple sub-agents. So think of it as instead of talking to one friend, talking to one coworker, and running ideas back and forth with them, and trying to develop with one person, you have Claude Code use multiple agents that can work in parallel. And that really, speeds up your development time. Multiple agents can go out and talk to MCP servers with other systems and come back and build their own specific task. And ultimately, you're going to get to results faster. It's also going to drive your AI token use count. So be mindful. You still need to orchestrate it. You still need to think of the structure of the program that you're trying to build, of the app you're trying to build, and then make sure that the Claude Code understands it, and the sub-agents that you can spawn from Claude Code follow your instructions. So how do you run Claude Code on AWS? So for us, for AWS, security is the foundation. Everything that we do is not an afterthought. It's we refer to security as being job zero. And as you walk through this process, you have your user machine on the left-hand side, and you first use your OIDC provider to log in, to get a login token, and then authenticate against Amazon Incognito. Amazon Incognito talks to AWS IAM, Identity and Access Management Services, which gives you permissions for a particular role. And then once you get those role permissions, you interact with the models. Claude Code that runs on your laptop interacts with the models, the Anthropic models that are hosted in the Amazon Bedrock service. And what would you do this? Well, as I said, your data has gravity, your data is very important. And you want to make sure that you are using your coding agents in a secure environment. You want to make sure that you have the logging in place for the API calls. As you work at scale and as you manage teams at scale and as teams collaborate at scale to build software and ship software, you have to have a consolidated single pane of glass view into that utility. As we talked, as I had pointed out before, these AI agents can use a lot of energy. They can use a lot of tokens. Tokens drive up costs. And you want to make sure that you have a consolidated view into what your team does, how it uses those coding agents, the security around the data that they put into the coding agent and that's passed to the model, and ultimately understanding what your overall spend is and where your data resides or ends up being, or is being shared to. So for those of us who lead teams, implementing Claude Code on AWS ultimately makes you sleep better at night, ensures that your data is secure, ensures that you have control of the environment, you understand what your coders are doing, how much they're spending, and how the tool is being used. There's certain benefits out there. no long-lived credentials, you have the audit trail, you have centralized access verification through IDPs. So as your developers leave, you can make sure that they do no longer have access to your code base or any of the artifacts that were used by Claude Code. Everything is encrypted at rest and in transit, and if you work with collaborators in the EU, you have those controls to make sure that you comply with the GDPR and EU regulations to keep the data localized in the EU region if you need to. So what's the developer impact? We talked about running Claude Code on AWS. 40% of developers tag Claude Code as being the most loved coding agent. And really what it means when using Claude Code for teams on AWS, it means that you can automate routine tasks, you can reduce the time context switching, you can have your entire code base in the model's memory, and you can really focus on architecture and not syntax. You still have to do the work, but you don't have to worry about how you type in that print line command. So if coding agents represent this powerful new abstraction layer, where do you run them? Well, the answer is you run them in a secure environment where your data, your architecture decisions, your business logic, and with your algorithms are well guarded. So on Bedrock, using the Anthropic models on Bedrock, you get VC isolation, zero data sharing, you get enterprise authentication, compliance, a full audit trail, and 5 nines of reliability. Your data and your knowledge is your real edge. So your brain's value, we talked about the 20-watt brain power. Your brain's value is much more than its neurons. It's everything you experienced, is your conversation with your colleagues, is your education, is your coding camps, is everything that you've done before. It's important to keep that knowledge, as you share that knowledge Claude Code, it's also important to keep that in a secure space. So for enterprises, you can keep your proprietary code bases, your docs, your all your knowledge repos, everything else in a secure place, and have the IDE tools to reference it. That goes for customer data, that goes for everything else that you may have in your organization. So your data is your private advantage. Every LLM was trained with publicly available data. Whether we're talking about Anthropic, whether we're talking about other LLM providers, the majority of data that led to that LLM creation is public. So using it accelerates your delivery. It won't always push the edge. What does make the difference is using your organizational data, your enterprise data, to enrich that model, enrich the way the Claude Code interacts with that model and how it develops the code that you want. So this is the competitive picture. You have a couple choices in AI tooling today. If you use GitHub Copilot, Microsoft Copilot, your code goes to Microsoft Cloud. If you use Cursor, your code goes to AnySphere startup. If you use Claude Code on Bedrock, your code stays within your AWS environment. Your code stays within the secure perimeter of your organizational account in AWS. It stays in your VPC, and you're using a tool that has been rated highly by other developers. So coming back full circle to the human ingenuity. How many of us have played Mario Brothers on Nintendo Entertainment System? Awesome, I love it, right? So that entire system, that entire game, fit into a cartridge, about 50 kilobytes of memory, including RAM size. Number varies from 40 to 50. We'll just settle on 50. It has 32 worlds, it has enemies, it has game logic, it's everything in 50 kilobytes. If you were to take a screenshot of it on your phone, first of all, if you took a screenshot on your phone, your display is so high resolution that size of the screenshot is going to be much higher. And I couldn't share a screenshot here because it's copyrighted, so we'll just talk about it. But the non-compressed image of the frame of that game, it's at least 230 kilobytes. That accounts for sub-VGA resolution and 24-bit color depth. AI cannot do that. to develop this takes human ingenuity.